which I assume that's our goal, right? Is this working? Okay, so number one, it says the Metropolis algorithm is used to generate random samples drawn from a distribution and is not an algorithm for optimization. So why does the Metropolis algorithm actually work in finding a possible letter mapping to decipher a text string? So what I'm kind of looking for is just maybe a brief description of not how the Metropolis algorithm works, but of what it's supposed to do, right? A brief description of kind of the goal or objective of the Metropolis algorithm. Okay, and then you should do a kind of a brief description of the goal or objective of an optimization algorithm. And then you should explain how, even though the Metropolis algorithm's goal is different from the optimization goal, there are certain overlaps in terms of what it's doing that helps us. I know, how do I say this, right? Because if we think about what, all of these things we've learned in the course, right, was, drawing samples from a distribution, and that's what the Metropolis algorithm is doing, okay? And if you think about what an optimization algorithm does, which is generally try to maximize or minimize a certain function, they are different. However, there is a certain amount of overlap that allows the Metropolis algorithm to help in this regard, especially in the context of this thing, right? So, brief description, goal and objective of Metropolis algorithm, brief description, goal and objective of an optimization algorithm, and kind of an explanation of, how running the Metropolis algorithm what is the right word? Points us towards something that looks like optimization. Does that kind of make sense as far as what I'm asking there for number one? So yeah, so now's the time to ask for like questions to clarify what it is I'm looking for in these questions that I'm doing, that I've given you. Okay. Okay, number two, how many possible cipher mappings are there? I think that's pretty straightforward. How does using the Metropolis algorithm reduce the number of possible cipher mappings to check? I think this is fairly clear in terms of how does using the Metropolis algorithm reduce the number of possible cipher mappings to check. Maybe you can just describe which basically probably want to include why the Metropolis algorithm will not check every possible mapping and why it's totally okay not to check all those mappings without I'm trying to phrase my tips without giving away the answer, without checking all those mappings, right? Like, we're not going to check everything, and it's okay for good reason, right? And that's so answer those questions, but and then in your answer you'll want to include this part of it. This is okay. Teaching. Let me just save this. I'll post this document online as well. Okay. So what is this? Final question clarifications. Okay. How does the algorithm propose a new cipher mapping? Okay. So what you'll want to do is explain what the kind of deciphering code, specific to your homework, basically. Okay, explain what the deciphering code does in proposing a new mapping. Okay, explain, what makes the method of proposal symmetric. Explain what it means for a proposal method to be symmetric. Right? There's a very specific meaning when we talk about the proposal being symmetric. There's a very specific meaning there, right? And that's a requirement of for the Metropolis algorithm. Okay? And I said the Metropolis Hastings algorithm doesn't require the proposal method to be symmetric, but this is a Metropolis algorithm, so the proposal method needs to be symmetric, and there's a very specific meaning for that. Explain what it means for the proposal method to be symmetric, and then explain why the kind of proposal method used meets the criteria for being a symmetric proposal method. Okay, and that's good with everybody else, though? All right. Okay, why do we use the Metropolis algorithm to reject a proposal mapping instead of a strict rule that only accepts increases in probability? I guess explain the consequences of strict increase rule, and explain how Metropolis algorithm avoids those consequences. So all of these are, this should be part of your, include this in your explanation, or include this in your answer. Make sure you touch on these topics. In addition to answering the question itself, right? Okay. No questions. Everyone's good? Okay. All right. Great. Great. Yeah.
Can you use terms from optimization like local maximum and simulated annual?
Sure. If you want to use that as part of your explanation, yeah, that's fine. Okay. All right. Draw and label the plate diagram for the document generation model. Okay. Label the diagram with short descriptions of each variable or distribution. Basically, there is a plate diagram in that handout, right? You're just going to redraw that thing, but you're going to kind of explain what each of those things mean, right? So you're going to, basically redraw the plate diagram in the handout. That's going to be worth like 2 points, right? Just can you copy the diagram? No problem. The points here will be explain what the variables represent, Okay, explain the distribution generating the variables. Okay, and with the subs, explain what the variables represent. Explain the distribution generating the variables, and then, explain basically the quantity of the subscripts. Okay, basically like number of documents in the corpus or whatever, etc. Kind of, because the purpose of the plate diagram is to show the relationships between variables and what depends on what. Okay, 6 and 7. From what distribution do we draw the parameter pi? Okay, also include kind of how we define that distribution with the hyperparameters. Okay. So from what distribution do we draw the parameter pi? Yeah. Okay. Include how we define that distribution with the hyperparameters. What does pi represent? That's very clear. What variable is drawn from the distribution that uses the parameter pi? Include basically a description of the distribution that uses pi, and yeah, I guess that's it. Okay, so answer these questions and make sure in your answers you're also including this stuff. Basically, for 7, same as 6. Okay. So from what distribution do we draw the parameter theta? Include how we define that distribution with the hyperparameters. What does theta represent? What variable is drawn from the distribution that uses the parameter theta? Basically include a description of the distribution that uses theta, right? And what that is. Yes? I'm sorry?
Like how to explain what a proportion is.
It's the portion, right? I mean, what does this variable represent, right? Mm-hmm. And it's it represents how we're going to get this other variable, okay? And yeah, I mean, like I know what a proportion is, okay, but it's the proportion of it's not just a proportion, it's a probability, right? And it's the probability of this other thing, and like what does it represent? It represents something, and we draw this other variable from that from a distribution that uses that parameter pi, right? So what is that other variable that we're drawing, okay? And what is that distribution that uses that parameter pi? I don't know, does that make sense? Okay, right. And then, where's pi coming from? It's coming from a particular distribution, and that particular distribution is defined with certain hyperparameters, right? Like what are, how are we defining that with the hyperparameters? And the same thing goes with the theta values. Is that okay? All right. Factor the joint distribution. So this is, I think we did this in class, part 8, and then basically just when you factor it out into the different pieces, describe each of the pieces. Okay, so I don't know what if there's anything that needs to be clarified there. Okay, and then the bold print here means it's a vector, right? So I guess make sure to distinguish between vectors and scalars, right? I think 9 and 10 are pretty, or let's see, 9 I think is pretty clear. Or I don't know, maybe it's not. I don't know if you tried 9 or if you tried 10. Basically, you'll need your calculator for 9 and 10, okay? Well, maybe you won't need it for 10, but you'll want the calculator for 9. And bring your calculator. Okay, and then these numbers will be different, but you'll update. You'll get this based on kind of these values that you punch in. Okay, I don't know. We're good? 9 and 10, is that good? Okay. I do want to add one more question to the pool of questions, if that's okay. All right? All right. Yeah, it's okay. I say so. Okay, so yeah, I think just do the calculations, right? Okay. All right, so I've got one more question to add to the pool. And I'll post this document online, so if you're not sure. Okay, so one more question to add to the pool. Okay, and that question is Gibbs sampling is considered to be a special case of the Metropolis Hastings algorithm. Okay. However, there is no p move that we calculate. We always accept the proposed value. Okay. And so the question is, why is it okay to always accept the proposed value in Gibbs sampling? Okay, and I would say for this one, look at the MCMC chapter 7 with the island politician example. And read the section on Gibbs sampling. And I guess you know, your answer should include how we propose new values with Gibbs sampling. Okay, right? Something about conditional distributions, right? And then explain how it is okay to just accept this straight up. Accept these. Is that good? All right. So this is kind of just getting at the, I don't know, I just want to make sure you understand a lot of the whys behind all of this MCMC stuff that we've covered. You know, we did a lot of this and we did a lot of that. And I just want to make sure we got a handle on, you know, why these things work. Okay. And so that's kind of the point of all of these questions, and I want you to go review your reading and make sure you understand all of this stuff. Okay. And then and yeah, you are allowed to just, I'm totally expecting you guys to just write out your answers by hand on these papers, and then for the final you just say like, oh, he asked this question, I'm gonna put my answer there. Okay, that's fine. And then and you're gonna turn in your handwritten notes. Okay, so that's, I'm collecting those. Okay, any questions? All right, well, I don't know, I guess for a lot of you this is your senior year. I know some of you guys will be back next year, but for many of you this kind of marks the end of your college experience, and you'll graduate, and I look forward to seeing you guys at graduation, and you know, you go forward from here. Some of you guys are going to grad school. Some of you will go start working right away. Others of you will take some time off to just relax or explore the world, or whatever it may be. You know, well, so I'll miss you guys, and yeah, you know, whatever you guys pursue in life, I guess you should ask I think it's always good to ask yourself, you know, is this helping me reach, I guess, is this helping me be the person I want to be? Okay, and it's not necessarily just about you being happy, because sometimes you know, the pursuit of a greater goal will require you to go through some periods of pain or of difficulty, and those times, as trying as they may be, are often very important for our growth as people. But you know, I would say there's, you know, life is precious and it's short, and there's no sense in spending time in a spot where you do not feel like you are growing or developing or becoming better. Okay. I don't want to also. I also want to separate this idea of your purpose and meaning and stuff from life doesn't necessarily have to come from your work. Okay. You might find you might find a job that pays the bills, is not personally satisfying, okay? And it's okay. It's reasonable to stay in that job, you know, like there's a lot of people who don't love their jobs, but they keep working in their job. And I want to say that's okay, because whatever time you spend at work is not necessarily the time that has to define your life, okay? You're probably not going to spend all of your waking hours at work, and you'll probably have time outside of work. And so, what it looks like, it's going to be different for everybody. But, if you're in a spot where your job in of itself is not satisfying and not fulfilling, it might be worth considering looking at other jobs. But during that time, you don't have to just feel sorry for yourself. There's time outside of work that you can use to then develop yourself. You can always be learning more, or if you don't want to learn more, then you can spend your time working with other people, volunteering. There's all sorts of things where you could invest your energies and draw meaning and satisfaction and fulfillment from those things, okay? Some of you may get married and have a family, and for me that's a very rewarding and fulfilling experience, and you might find that you're willing to put up with this unsatisfying job because it allows you to provide for your family and things like that. Life it's very rare where you get a situation where you have complete happiness and satisfaction in everything. But I guess all to say, when you face difficulties and you're faced with challenges, just you can ask yourself, what am I able to do about my situation that will help me to be the person I want to be. And sometimes it means changing jobs, sometimes it doesn't require that. But I think there's always opportunities for self-improvement, and I want to encourage you that even after you finish college, you're always going to be working to improve yourself and making yourself better. And yeah, I guess that's what I want to say. Take care of your health. Take care of that. Your physical and your mental and spiritual health. Those are all important aspects. Spend time with the people you love, because it's always good to have people in your life. Okay, so. Anyway, it's been a great pleasure being your teacher. A lot of you took multiple of my classes, and I'm very flattered and honored that you enrolled in my course all these times. And so I hope the courses have been a positive experience. I hope you feel like you have learned something and gained something beneficial for your development and for your future careers. So wherever life takes you, I wish you guys all the very best, and congratulations to all of our graduating seniors. So anyway, that's all. So hats off to you guys. And yeah, I guess that's it. We'll end a little early unless we have questions or anything. Okay, that's it.